This is Joe narrating a PowerPoint in science in the unit on physical science. It's lesson 1 about atoms and molecules. This is found on page 542 in the Kaplan book. Here's the new vocabulary. You should know what an atom is. Subatomic particles include protons, neutrons, and electrons. Elements and chemical symbols, compounds and chemical formulas, mixtures, molecules, covalent and ionic bonds. So all matter is made of tiny particles called atoms. An atom is the smallest unit of matter that has the properties of that particular element. It used to be thought that atoms are the smallest particles of matter, but now we know that there are particles that make up the atom. These particles include the positively charged protons, the negatively charged electrons, and the neutrons, which have no charge. The protons and neutrons are in the nucleus of the atom, and the electrons can be thought of as orbiting the nucleus. If an atom has the same number of protons as electrons, it has no net charge because the positive charges of the protons balance the negative charges of the same number of electrons. When an atom has a charge, it is called an ion. A positive ion might occur if an atom were to lose an electron. So if it loses a negative charge, its net charge or its remaining charge is positive. If an atom gains an electron, its net charge will be negative. So on the GED test, you might see a diagram of an atom, and you might have to identify electrons, protons, and neutrons. This is a periodic table. The periodic table is fundamental to chemistry. Every atom has certain characteristics, mainly based on the number of protons in the nucleus of that atom. For example, carbon on the upper right has 6 protons. That's what the number 6 above it means. Its weight is 12 atomic mass units because it has 6 protons and 6 neutrons. So those are the main determinants of the weight, is the number of protons plus the number of neutrons. The electrons are tiny and have very little weight. The periodic table is arranged in rows and columns. The columns up and down show elements with similar properties. And the rows from left to right show an increase of 1 electron and 1 proton as you go from left to right with each subsequent column. Chemical compounds are substances formed of 2 or more elements, chemically combined in a definite proportion. The compound is specified by its chemical formula. For example, here you see 4 common compounds. Water in the upper left is made up of 1 oxygen, the large green structure in this model, and 2 hydrogens, the purple structures in this model. The formula for water is therefore H2O, meaning 2 hydrogens and 1 oxygen, and that is the chemical formula for water. Ammonia, which is a household cleaner, is made up of 1 nitrogen and 3 hydrogens. Its chemical formula is NH3. Carbon dioxide, which we exhale, is made up of 1 carbon and 2 oxygens, so its chemical formula is CO2. Hydrogen peroxide is used in beauty shops and as a sterilizer, and it is made up of 2 hydrogens and 2 oxygens. Its chemical formula is H2O2. This is showing a reaction of two atoms of hydrogen with one atom of oxygen. So if you have hydrogen and oxygen reacting together, they will react and form water in a very explosive type of reaction which releases a lot of energy. So you have two substances combining. If they are different substances, they are form a compound. If they are the same substances, for example, hydrogen H2, which is in the air, that is two atoms of hydrogen coming together to form a molecule. That is not called a compound, but it is still a molecule. This is a very big molecule. This is a vitamin that we all need to sustain our lives. This is vitamin B12, so you can see how complicated molecules can become. This molecule is made of nitrogen, hydrogens, carbons, oxygens, and there's a cobalt, which is a metal, in the center of this structure. Mixtures are physical combinations of two or more substances that still keep their own properties. For example, if you were to mix M&Ms together, you could pick out the orange M&Ms from this pile, and the orange M&Ms would keep their own characteristics. Mixtures exist in the chemical world too. For example, salt water is a mixture because you can evaporate the water from a glass of salt water and you would be left with just the salt crystals. So in summary, matter is made up of, on the left, pure substances. The pure substances, which each substance having their own characteristic property, can be an element. For example, gold is often found in nature as its pure substance as an element. Or it can be a compound where two atoms of different types combine via chemical means. For example, water is a compound. Or you can have mixtures, which are just physical combinations of two or more substances, each keeping their own properties. You don't have to know the different types of mixtures, but you can have a homogeneous mixture where everything is mixed together pretty well, or you can have a heterogeneous mixture where the substances that make up the mixture will eventually separate out, like oil and water in your salad dressing. The oil will rise to the top and the water will settle on the bottom until you shake it. Atoms can bond together to form molecules. There are two types of bonds discussed in the book: ionic bonds on the left and covalent bonds on the right. In an ionic bond, one substance, for example, sodium here, gives up an electron to another element, chlorine. That sodium, because it gives up the electron, becomes positively charged. The chlorine, because it gains an electron, becomes negatively charged. And the positive and the negative charges attract each other to hold the substance together. That's an ionic bond. Basically, elements held together by electric forces, positive and negative charges. A covalent bond is where two atoms share an electron, and because they share the electrons, they still have no charge, but are held together firmly. In life, substances that have ionic bonds tend to dissolve readily in water, whereas covalent bond substances do not.